Hi everyone, welcome to this session on CS22071 Agile Methodology presented by R. Samundi, Assistant Professor of Computer Science and Engineering. In this session, we will look into understanding software development as a complex adaptive system. Topic from Unit 2 Agile process. Here, first let us understand what is a software development. What are the process involved in a software development? So, for this definition as software development involves many interconnected people, tools and decisions that continuously adapt to changing requirements, technologies and market conditions. It behaves like a complex adaptive system evolving through feedback, learning and interactions with outcomes that cannot be predicted solely from the starting condition. And next we will see whatever topic today we are going to cover means the challenge in software management. So, why traditional methods are struggles and the software is not equal to manufacturing. So, software is different from manufacturing. So, here we will understand what is the key difference between physical and knowledge work, system thinking, seeing software organization as whole system. Next one is complex adaptive systems in software, feedback loops, emergent behavior, governing rules. And next one is theory of constraints, identifying and managing bottlenecks. And next one, managing uncertainty with buffers. The types of uncertainty and practical strategies. And next one, agile planning and tracking. How to plan adaptively and track real progress. And eighth one, metrics that matter. Production and financial metrics for decision making, waste reduction and flow, improving delivery speed and value, organizational maturity and continuous improvement from basic tracking to ROI driven culture. So these titles and all in this session we are going through. Next slide we will see what are the challenges in software management. Many software projects waste money, miss deadlines and lose market opportunities because of poor management decisions. So, while developing the software, the management decision plays a vital role. Software development is a skill knowledge work, not factory style or repetitive labor. We must compete in a global market including low cost economies, quality and speed are differentiators. Better management methods help deliver more value faster and more predictably. So, current reality projects are often late, over budget, and deliver fewer features than promised. Here we will see the software is not equal to manufacturing. It is not an easy task when we are comparing with the manufacturing with the software. Manufacturing is predictable. Inputs and outputs are well defined and process follow fixed step. Software is creative, exploratory and uncertain. Requirements and solution evolve over time. Applying rigid manufacturing process to software leads to estimation errors and unrealistic expectation. So, accurate estimates in software are often fiction because complexity and change are constant. From a business view, this makes software look out of control unless managed differently. Yes, software can be managed. The work is complex, but it is not chaotic. We can manage outcomes with a rigid approach instead of trying to eliminate uncertainty. Plan for it and control the variables we can. The theory of constraint teaches us to identify bottlenecks and gives buffers to observe unpredictability. Here, the goal is to deliver reliability without overloading teams or adding waste. Next on is system thinking. From Peter Senge's fifth discipline, see the organization as an interconnected whole, not isolated departments. This mindset creates a learning organization that improves continuously, combining system thinking with theory of constraints help break limits to growth constraints that cap performance. Here, the end goal increase the profitability and ROI by improving the system, not just the individuals. In next slide, we gone through the software as a complex adaptive system. A complex adaptive system have many interacting parts constantly adapting to changes. They rely on feedback loops to guide improvement. Complex adaptive system evolve over time, showing emergent behaviors, patterns you can't predict from initial condition. Software development fits perfectly into this definition. And next one, the adaptive behavior. The desired outcome of your system is equal to adaptive behavior. In software, that means delivering working valuable code to the customer. Feedback loops, review, test, customer input steer the team toward better result over time. Without feedback, the adaptive behavior deteriorates into chores. Next slide is emergent properties. Emergent properties are characteristics that arise during operation, not by direct design. Here examples in software projects, a fun collaborative team culture, adoption of tools like bug trackers or CI pipelines. These emerge from simple guiding rules, not from detailed micro management. And next one, simple governing rules. Complex system can be guided by a few clear, simple rules. So rules can be transformed into influence behavior, and that influence behavior generate the results. So agile leaders define the boundaries and priorities, not every step. So expect both the positive and surprising outcomes, learn and adjust. So these are the simple governing rules. In next slide, we will see what are the world and versus new model. In old model, log the scope, then adjust time, budget later, After that, we create a waste in paperwork and rework. Goal used to be perfect reliability, which is unrealistic for complex knowledge work. New model accept the requirements will change, and uncertainty is natural. Plan adaptively, manage scope, time, a resource together. So there is a only difference in a old model and new model is the new model will accept the uncertainty, but in old model it won't accept uncertainty. So that's why it is unrealistic. So that's all about the world versus new model. Now next move into next slide, thinking in system. Human tend to think in a simple cause, that cause produce effect chains. Real system operate in nested feedback loops with multiple influences. Small rule changes can cause big ripple effects across the system. A good management equal to knowing the rules, spotting emerging patterns and finding leverage points. And next we will see in the managing uncertainty. Uncertainty is normal in software. It does not mean the work is uncontrollable. Buffers act as a shock observers for unpredictability, a key constraint to protect people, time, scope, budget, resource. The art is matching the right buffer to right constraint. So that's all about the managing uncertainty. Next we will move into buffers. Buffers protect against the missed deadlines or blown budgets. Time buffer for time constraints. Budget buffer for cost uncertainty. Scope buffer for requirement flexibility. More uncertainty can cause the larger buffer needed. Example, mature teams may need only 15% buffer. Startups may need up to 200% buffer. So it's all about the buffers. Now next we will move into 4 uncertainty type. Variation, predictable difference. Example, performance difference between team members. Forcing, risk you know but you don't know if they will happen. Unforeseen, unknown technical challenges that require big buffers. Chores, unstable goals or shifting market conditions that need major adaptability. Next, we will move into next, that is local safety problems. Developers pad their own estimates to protect themselves. This creates hidden buffers that bloat timelines, aggregating uncertainty at the project level reduces waste, manage safety at the system level, not per task. So that's all about the local safety problem. Now move into next, agile planning and tracking. Plan in large chunks instead of micromanaging every task. Use critical chain buffers to track overall health of the project. Simple traffic light tracking. Green means it is a safe. If it is yellow means it is a risk. If it is a red means urgent intervention. Manager's role is to facilitate delivery, not micromanage the execution. And the transparent management. Leaders set system rules and track key performance indicators. He or she shares the progress, arrests, and issue openly with all stakeholders. Hold monthly review session to solve problems and improve the process. And next one is transparency build trust and accountability. And next, the production metrics. Track throughput, that is value delivered, and inventory work in progress. Avoid measuring only effort hours. Focus on business outcomes. Use cumulative flow diagram to show delivery speed and backlog levels. And moving into next, the financial metrics. Throughput accounting focuses on value flow, not just cost cutting. Here, the key measures are throughput, investment, operating expense, net profit, and ROI. It aims to increase the throughput while reducing the investment and operating expense. Here we will see what are the waste and how they will flow. Waste equal to extra cost without added value. A smooth flow ensures no bottlenecks and steady output. Deliver in small batches to accelerate customer feedback. Avoid perishable requirements, features that became irrelevant before delivery. And next, the organizational maturity. Maturity stages can be categorized as 5. Number 1, basic data tracking. What are the requirements? And next one is process awareness. And third one is predictability. Fourth one is business driven metrics. And fifth one, ROI focused, failure tolerant culture. So, Ajay helps move up the stages aligned with the TOC for sustainable profit. Here, TOC means theory of constraints. What are the constraints for sustainable profit? And moving into next, it is the overall about this session. Agile is not just adaptability, it is about lean, profitable development and theory of constraint plus lean removes the bottlenecks and makes agility measurable. So here winning formula is deliver the high value faster, more consistently than the competitors using Agile. So thank you.